on. And why do we want this linear regression line? We want a regression line because we want to use that regression line for prediction. And companies use this all the time. If you ask business people, I have a lot of friends in business, my siblings in business, a regression line is one of the most used statistical methods in the business world because oftentimes we're trying to predict things. And what happens is, those of you who are talking about putting a banana in it, people will take the data and they will re-express it using logarithms so it's linear. Linear regression lines are easy to read. You've had this since algebra. Everything you've seen right now you've had since algebra, so that's why it's easily used as well. Again, the main reason for this is for prediction. If you are just drawing a regression line, a model of what's going on, you want to draw something, I talked about this yesterday, where approximately half the points are above, half the points are below. Okay? Something similar to this. Now, what I want you to do right now is I want you to find that regression line. So calculate it. You should get to the screen right now in your calculator. Y is equal to A plus BX. And you get A, you get B, you get R, and you get R squared. If you do the Y1 thing, it's automatically in your calculator. You can look at the graph, the line will pop up. If you didn't, you still get everything you need. It's not the end of the world. Okay, so did everyone get negative 20.7? Yes, okay. 1, 1, 0, or 1? Okay, and then 12.533? R squared is 0.55, and R is 0.74. Okay. When you're writing an equation for this line, I want to know what this line is. B is your slope. A is your y-intercept. Does that ring a bell from algebra, remembering slope, y-intercept? I know it's been a while for some of you guys. Now, when writing this line, I'm going to quick take a picture of this because I'm running out of room. Okay, I'm going to expect one of two things on the EP exam or for me. When you're writing this line, I'm going to ask for a regression line. When I ask for a regression line, I just told you that regression line is y is equal to a plus bx. Now, we use the regression line for prediction. So there's one of two options for you. You can choose. I think one option is easier than the other, but again, it's totally up to you. A regression line is used for prediction. And because it's used for prediction, we take an x value and we try to predict y. So one thing that will be required of you is your y has to have a hat on it. That hat on it means that y is used for prediction. It's a predicted y. Next I write and I say, okay, a is my y-intercept and my a here is negative 20.711, okay? Plus, b is my slope, 12.5337 times x. X is not predicted, x is an actual value. We know an actual value, we're trying to predict what's going to happen. That's the reason we use regression. Now, if you choose to write it this way, you have to tell me what x is and what the predicted y is. You have to label it. So we're still using the data from yesterday. And the data from yesterday, our x value was the weight of a mixer at Walmart. That's one option for you. If you're a person you really like that y and that x, go for it that way. Yes. We're not even doing state plan do right now. This is, I mean, yeah, it is kind of a do stuff. It's because you're actually calculating stuff, but no state plan do it right now. This is, I have to set it up first. We're going to do it in like next week it starts. I just need to make sure you have your regression done. This is actually what I prefer. This is like the preferred method. When you write your equation, instead of writing y hat, I'm going to write the predicted cost is equal to A from my calculator, negative 20.7111 plus B from my calculator, 12.5337 times X. What is X? The weight of the mixer. I just showed you two different ways to write the equation. What's different with these two equations? The first way versus the second way? One uses y and x, the other one, so if you look here, this one here uses y and x, but then you have to define what y and x are. I want to be really clear here. If you don't define what y and x are this first way here, so look at my cursor. If you don't define what y is as a predicted cost, you will get docked points because it needs to be in context. So this is why I don't like this method. I like over here. Because automatically you just get used to putting in what's the y? Well, that's my cost. It's my predicted cost is equal to my y-intercept plus my slope times my x value. And my x value is my weight. Again, this is the way I prefer, but I realize there's some of you in here who you just don't want to get away from that x and that y. Are there questions here on just using the calculator to get a regression line? So what did I just do? I just wrote a regression line here. I figured out what this line is. Questions? Okay, now a couple things about the regression line. Obviously in stats we need to go more in depth. We need to tell the story behind those numbers. What does the slope actually mean? What does the y-intercept actually mean? So a regression line, just statistically, is a line, the definition, a line that describes how a response variable changes as the explanatory variables changes. You pay more, or your weight mixer, the mixer weighs more, you're going to pay more. The mixer doesn't weigh as much, you're not going to pay as much. As that weight changes, the cost changes. Write the definition down. The problems I'll print out for you. Now, a couple things about your formula sheet. On the front page, turn to that when you're done writing the definition. I do want you to write this down on your notes too. You are going to need these formulas when you take the test. This is section 3.2, yes. Oh yeah, you're right. The first equation on your formula sheet is just the basic regression line equation. So it's saying your predicted y is equal to b naught. They call b naught your y-intercept here. And b sub 1 is your slope. And there's a reason, I mean, hopefully everyone knows that, but there's a reason you need to know this, because once in a while, they won't give you an L1 and an L2. Let me be clear. They will not give you an L1 and an L2. They will only give you what the data is, so they'll say the weight of the mixer and the cost. They'll give you the correlation coefficient, And then they'll give you the averages. So they'll give you the average weight and they'll give you the average cost. And you have to come up with a regression line. And I'm going to give you an example of that in a second. But here's the formula for B net when this happens. Notice that Y bar is your average Y. X bar is your average X value. This is the equation to find your y-intercept. This is the equation to find the y-intercept. It's in your formula sheet. I'm going to give you an example of it in a second. And this is the equation to find your slope. So I have some definitions, but let's jump to a problem where we actually have to use this first, because that seems a little bit natural than going back and saying, okay, well now let's do definitions. So let's actually use those equations right now. Previously what we did is we put in L1, L2, came up with a regression line. Now I'm not going to give you data like that. Give you another second here. So we already found an equation with L1, L2. Now let's read through this problem. The number of miles in thousands for 11 used Hondas have a mean of 50.5 and a standard deviation of 19.3. The asking prices for the cars had a mean of 14,425 and a standard deviation of 1,899. The correlation for these variables is R is equal to negative 0.874. Find the equation of the least squares regression line and explain what change in price we would expect for each additional 19.3 thousand miles. We don't have an L1, we don't have an L2. We just know that we have an X variable. Our X variable, is it going to be the number of miles or is it going to be the price? What's my explanatory variable here? Do you think, what makes more sense, to look at the number of miles and try to predict the price, or take the price and try to predict the miles? It makes more sense to take the miles and try to predict the price. So that's what you always kind of want to figure out first. What is my X value? What's my Y value? My X value, we're going to say is my miles. And then I'm going to try to predict the price from it. For the cutout, I'd say probably 3 lines, yeah. First thing you want to do is you want to figure out what is the X value, what's the Y value. Once you find out the X value and the Y value, then take the data that they give you. The mean for the miles, the X bar, is 50.5. The standard deviation is 19.3. For the price, the mean is 14,425. And a standard deviation of 1,899. The correlation is negative 0.874. So ladies and gentlemen, what should we be able to tell right away about our slope, knowing that what our correlation is? Our slope should be negative. Why? Because the relationship has a negative direction. We need to figure out our slope now. So you're going to look at B sub 1. Step 2, slope. slope is b sub 1 is equal to, what does it say? Your r times what? Yes, sy over sx. So calculate that now for me. B sub 1 is equal to negative 0.874 times 1,899 divided by 19.3. Can someone plug that in their calculator and tell me what that is? Brogan, did you get it? Negative 85.996. Here's my slope. Now I need my y-intercepts. B net is equal to the average y, right? Plus or minus? Look at your formula. Minus, then what? B sub 1, your slope, times x bar. Again, that's on your formula sheet for the AP exam. We just wrote it above on the notes as well. So I say B sub naught is equal to y bar, 14,425. Right? Y bar minus B sub 1, we just found that. Negative 85.996 times x bar, 50.5. $18,000. What? 600? 767? Can someone confirm? Yeah. 767? Okay, thank you. Okay, so we have my b sub 1, we have my b sub 0, we have our slope, we have our y-intercept. We can write the line now. Rewind again. First problem we did, L1, L2, just plug in your calculator. Second one, they don't give you that. They will give you all this information though. All right, my slope. So what is my y value? My y value is my price. So I'm going to put my predicted price is equal to my y-intercept, b sub 0, which is 18,767, plus or minus 0.874 times my x value, which is my miles. Here's my regression line. Again, follow those steps every single time. Step 1, just write down your data. Make sure you decide what is your x, what's your y. Step 2, find the slope. Step 3, find the y-intercept, and then plug it into your equation. Are there questions?
So it's minus 0.874?
Yeah, why is it minus 0.874? Because the x is negative. If you put plus or negative, that's the same, so it's not a big deal. Because the slope, oh, I'm sorry, no one caught that. Thank you, Lizzie. That's my R. My slope is here. So I should have put what? I accidentally put my R there. I need to put my slope there. Forgive me. Okay, let me just rewrite it for you. Okay, so I need to write my equation. Y hat is equal to b sub 0 plus b sub 1 times x. My y is my price is equal to b sub 0, 18,767 plus b sub 1. Here's b sub 1. Negative 85.996 times miles. Forgive me. Should we do definitions tomorrow? Okay, so what you can do is you can start the next assignment if you want to kind of stay up on top of things. The only thing you won't be able to do is to interpret. Okay, so we'll interpret tomorrow and we'll talk about residuals tomorrow. You should be able to find all your regression lines though. It's just kind of plugging and chugging. It's not that big a deal. So I would encourage you to kind of get caught up or get ahead on your homework tonight. I will post it online and then you can finish it tomorrow. Any other questions?